What is going on, you guys, and welcome back to the channel. In this video, we're going to go over 7 ways in which you can improve your Python code. So to start off with, we're going to have a look at ternary operators. So let's say you have a list of numbers, much like I have here, so my numbers, and it's a list of numbers 1 to 5 or whatever numbers you want. Now, let's say we want to print out a message if a certain number exists. So if 5 exists, we want to print out 5 exists. If it doesn't exist, we want to say 5 does not exist. So one thing we could do is write a standard if statement like so. So if 5 in my numbers, and then message equals 5 is in there, and then else message equals 5 is not in there. And then we can just print it out. And on the side, I have my terminal open. So if I run Python 3 and then main, we get 5 is in there. All right. So the thing with ternary operators is that it gives us a way of writing conditional statements such as this. So such as the one that's taken up 4 lines into 1 line. And we can do that just by writing it like this. So message equals 5 is in there if 5 in my numbers, else 5 is not in there. So if I go to the line below and print out message, we should get just the same as what we got last time, and we get 5 is in there. So that's what a ternary operator is. You have the first part is the return value if the condition is true, so 5 is in there, and the part after the else is the value that you get if the equation or the expression evaluates to false. And another thing to note is that with ternary operators, you cannot use else if, so you, like as we normally would or you would with Python if statements, so you can't have that in there. You can only have if and else, and that's about it. But ternary operators can be pretty useful, especially if you're writing a very simple if statement with an if and else. You can condense it into 1 line just like that. As a nice follow-on from ternary operators, we now have a list comprehensions. So let's say again that we have a list of numbers. I've created my numbers again, but with some more numbers from 1 to 8. And we want to create a new list out of this list where each element has been squared. So one way we could do this, or the standard way, would be to create a squared numbers list, so an empty one. And then we can loop through my numbers, so for number in my numbers, and then squared numbers dot append number and square each number, and then we can just print it out. So print squared numbers. So if we run this, we get back a new list, but that list is the my numbers list where each element has been squared. So just like our ternary operator situation from earlier, we can take these 3 lines, so this squared numbers up until the end of the for loop, and we can turn that, or we can compress that into a 1 line. So we can say something like this. So we can do squared numbers equals, and then square brackets, and then say number squared for number in my numbers. And then we can print that out again. And if we run this, we get back the same result as we did from before. So the way in which a list comprehension is structured is that you first have the expression, so this number squared, in our case, then you have the item, so number, and then the iterable, so my numbers. And that's basically how a list comprehension is made up. And we can go one step further as well. So to kind of take from our ternary operators, we can say, let's say we want to create a list of squared numbers from my numbers, but only square the numbers that are even. So we can do that by saying even numbers, or even squared numbers, but in this case leave it there, and do the same. So number squared for a number in my numbers. And this may cut through the page, so I'm just going to shrink this a bit. And then after that, we can write a condition. So we can say if number and then modular 2, so to check if it's even, equals 0. So like this. Now if we print out even numbers and run this, we get back 4 elements as there are 4 even numbers in my numbers, and where each even number has been squared. So you can also extend a list comprehension to also include a condition. Now you can also, as well as doing this with lists, you can also do set comprehensions. So for example, let's say we have another list of numbers, and we'll say my numbers again. And this time I'm going to add a few duplicate numbers. So 1, 1, 2, 3, 4, 4, 5, 5, 6, 7, 8, 8. And we want to create a new set out, or we want to turn this into a set. So what we can do is say unique numbers. I mean, you could literally run set like this, and that should do the trick. But we're going to extend on this in a second. So we can say unique numbers equals, and then instead of the square brackets, add the curly brackets and say number for number in my numbers. And then we can print out unique numbers. If I run this, we get back a unique set of numbers. However, we could of course just cast this to a set, but this becomes much more useful if we add if we say we only want unique numbers that are even. So if number and then modular 2 equals 0. So if we run this now, we get back all the unique numbers, or a list of unique numbers that are even. So that's list comprehensions and set comprehensions. Next, we have the enumerate function. Now this is useful when you need a counter whilst looping through an iterable. However, you may be thinking there's also another way of doing that, and that's just by getting a list. So I've got this fruits list here, and saying for I in range and then length fruits, and then printing something like we have the counter, so I can be seen as a counter, and then fruits, and then the fruit itself, so fruits and then I. And if we were to run this, we get 0, so we still have our counter, and then we also have the element in the list. However, with the enumerate function, you can loop through an iterable in a much more cleaner way, and also personalize the way in which you start counting. So I'm going to remove this, and instead I'm going to write for counter and then fruit in enumerate, not enum, but enumerate, and fruits. So we pass it the iterable, and then we can print this. So we can say counter and then the fruit. So now if I run this, we get the exact same result. However, sometimes you may want to start the counter as something at different values. So you may want start value to be 1. And if you can do that just by expanding or adding another argument to the enumerate function and say start and pass it the value that you want to start it on. So with 1, we have apples starting at 1, bananas 2, oranges 3, and pears 4. So that's how the enumerate function works. It's a much cleaner way of having both a counter and an element in the list, or the iterable, within the for loop. Let's say now that we have 2 lists, so names and ages, and we want to create a dictionary out of them. So let's say we want to create something that is modeled like this. So we'll have Alice and then her age, and then Bob with his age and Carol with her age. So let's say we want something like this and we want to use these two lists. So one way we can do that is fairly simple. I mean, it's just one line. We can say people equals dict and then zip and pass in names and ages. And if we print this, we should expect the list that we defined earlier. So Python 3 and then main. And that is exactly what we get. So we get Alice 23, Bob 34, Carol 45, where the name is the key and the age is the value. However, if you're not familiar with this or if you haven't seen this before, you may be looking at this zip function in a weird way. Like, what does it do? So the zip function can take a number of iterables, so in our case, names and ages, and iterate over them in parallel. So what does that mean? With names and ages, it will look at Alice and 23 at the same time, then Bob and 34 at the same time, Carol and 45 at the same time. Now, as it goes through each of these two elements, it will throw them into a tuple. So rather than me like adding more words to this, let's actually have a look at what it looks like. So we can say for item in zip, as zip returns an iterable, we can say names and ages, and let's print out item. So if I run this, you can see a tuple for each element in the list. So Alice and 23 as a tuple, Bob and 34 as a tuple, Carol and 45 as a tuple. Now what this dict does, so as we wrapped it around this dictionary, it takes this and it takes the first element of each tuple, creates a key out of it, then it takes a second one and creates a key out of it. So this is pretty much two things in one. First, how to take two lists and turn them into a dictionary, and then also looking at what this zip function does. Sometimes with dictionaries, you may want to have default values. For example, let's create a dictionary that represents a school where the key will represent the course, so history, and the value will represent a list of all the students that attend that course. So we'll say Alice and Bob. And then if we print this, so print school and then history, run this, so Python, we get back Alice and Bob when we try to access the history keyword in school. But let's say we want to access the computer science one. So if we did school and then computer science, and if we run this now, we get a key error. So computer science does not exist in the school, in our school dictionary. So one way to combat this is to use the default dict, and that comes from the Python standard library. So up at the top of the file, I'm just going to import from collections, import default dict. Now, instead of defining it like this, so I'm just going to comment this out. We can say school equals default dict and pass in a list. And remember not to add the parentheses, make sure you just write list as is. So if I now say school, and let's add one anyway, so we'll say art equals and a list of students, so Michael and Jane. If I print out school and art, if I run this, we get back Michael and Jane. However, given that we haven't added, let's say, computer science again, if I try to print that out, we should instead get back an empty list. So if I say computer science, run this, we get back an empty list. So we don't get an error, but we get an empty list. With that, we can also say, given that we know that the default value for any key is a empty list, we can also do school and then computer science. and we can append it and add in, let's say, another student. So we'll say Abdul. And now if we run this, I wrote this above the computer science line, so the print statement. So we should now see Abdul inside computer science. All right, so that's how the default dictionary works with Python. But let's say instead you don't want to initialize with a list, but rather a string. You can also do something like the following. So we'll say string dict equals default dict, and you don't write string or you don't write str like this. You have to write lambda and then the value that you want in there. So we'll just say some string. So if I try to access something in string dictionary, say some random string here, we get back, I need to print it out. So if I run this, we get back some string, as that is the default value. For an integer, you can do it like this. So create another one, default dict, and add lambda, and we can just give it a value, say 20. Or if you want to return none for whatever one you want to access, you can just do it like that. So default dict and lambda none, and that works as well. So that's how the default dictionary works from the Python standard library collections. Very useful. I've used it in many cases, and yeah, it kind of brushes past some of the hard errors that you get when trying to access a key inside a dictionary that doesn't exist. Say that you have two dictionaries and you want to combine them. So we want to combine our fruits dictionary with vegetables, where the key is the fruit and the value is, let's say, the quantity of how many of what we have. So let's say we want to combine the two. There are two ways of doing it. So the first version is, if you're using Python 3.5 or higher, you can do it this way. So we can say food equals, and then asterisk asterisk fruits, and then asterisk asterisk vegetables. And then if we print this out, so if we print out food, we should get back a merged version of the two dictionaries. And that's exactly what we get. Let me just expand that so it looks a bit cleaner. So we have apples, oranges, pears, carrots, avocado, and lettuce. So we've combined our fruits and vegetables. The other way is, in my opinion, a lot cleaner, but this is only available for Python versions 3.9 or above. I'm currently using Python 10, so hopefully you guys are too. So with this, we can say food equals fruits, and then this pipeline, so this vertical line, and vegetables. And if I print that out, food, run this again, we get back the exact same result. So this one here, the second time it's been printed out, and it's the exact same as what we had before with this double asterisk version. So yeah, that's how you merge two dictionaries. To save the best part until the end, we now have pattern matching that came with Python 3.10. So if you've come from another language like Java or C++, this is pretty much like switch statements. Or if you only use Python, then if you're used to writing a lot of if and else if statements, pattern matching is a good way to kind of write that in a much more cleaner manner. So let's take a look at an example. So let's say you have a language, and we'll set this to Arabic. And now we will have an if statement. So if language equals, let's say, English, then we want to print out, you can speak in England. I mean, with English, you could pretty much speak in most places, but just to keep it simple, if language equals Spanish, then print, you can speak in Spain if language equals Arabic, print you can speak in Jordan. If language, or else if language, I keep saying if, else if language is said Farsi, print you can speak in Iran. And then else print I don't know about your language. Okay, so you're probably used to seeing if statements, or pretty deep if statements like this, where you have many else ifs, at least some point in your Python journey. So if we run this now, and yeah, so we have the language set to Arabic, so we should get you can speak in Jordan. And if we added, I don't know, just some random text here, say I don't know your language. Okay, cool. Now with the switch statement, we can, or the pattern matching, we can use two new keywords, so match and case. So instead we can say match, and then what we want to match, so the variable in this case, so language. And then underneath that, we can say case. And I'm not sure why my VS Code isn't picking this up, but case, and case like this, and then English. And we can print you can speak, or let's just take this here rather than typing it out all again, like that. And then we have case Spanish, and we just turn that into Spain. Case Arabic, and print that out, say Jordan. Case Farsi, and say Iran. And then we have the default case. So instead of the else, we can say case and then underscore. So this is where if it doesn't match with any of the above, then do this. So we'll just say, I don't know that language. So if we run this, we get, so the second one is coming, so the second print is coming from our match case, or our pattern matching. So we're getting you can speak in Jordan. If I change it to Farsi, we get Iran. So that is structural pattern matching. That's the technical term for it. Very useful. I mean, I don't know how many people are now aware that this is in the latest versions of Python. So any version of Python that is 3.10 or above, you can now make use of pattern matching, which, I mean, it's a long time coming. The language needed it. A lot of people were asking for it, and now it's finally here. But anyway, if you enjoyed this video, if you found this, if you got some tips and tricks out of this and want to employ it, please leave a like and subscribe. Also, feel free to comment. There is also a Discord server which you're free to join to ask any questions. And otherwise, stay healthy and safe, and see you in the next video.